Okay, so we're going to go over the problems that you just completed. If you got them all correct using the chart method, then you may feel like you're confident enough to just skip through this, which is fine. Otherwise, you may want to at least check out a few of these problems and watch the solutions to get yourself feeling more comfortable before you move on. The first question asked us to balance the equation between what we call iron sulfide and hydrochloric acid, and it creates a substance called iron chloride plus hydrogen sulfide gas. So again, what we always want to do is check if it's unbalanced. It is unbalanced, and then we go ahead straight to making our chart. We're going to have iron, sulfur, hydrogen, and chlorine. Divide up our reactant side and our product side, and make our rows. We'll immediately start off by counting off how many atoms of each element we have on both sides. We have 2 irons on the reactants, 1 iron on the products, 3 sulfurs on the reactants, and 1 sulfur on the products. We have 1 hydrogen on the reactants. We have 2 hydrogens on the products, 1 chlorine on the reactants, and 3 chlorine on the products. We want to start off with the most complex substance. This one's, you could go either way. To me, I would pick this iron sulfide here since there's 2 irons and 3 sulfurs, but you could get away with, going with this one as well, I suppose. It really doesn't matter either way because you'll probably end up balancing iron first, but you should be good either way you do it. So I'm going to go ahead and go with iron sulfide, and I'm going to balance iron first. So if I have 2 irons on the left, 1 iron on the right, I'm going to go ahead and put a 2 in front of my iron chloride here, which will leave me with 2 irons on the product side. That's going to leave me going to my sulfur next, because that's the second substance in my iron sulfide. And since I have 3 sulfurs on the left and I have 1 on the right, the sulfur is going to need to have 3, and so the hydrogen sulfide over here, I'll just put a 3 in front of it. And what did I forget to do in the previous step? I forgot to address the fact that I changed my chlorines. So let's address that first. I'm going to go ahead and erase that just to make sure we address it first. So remember, we always want to recognize that when we put a coefficient in front of something, we change what we're wanting to change, but we also change the other substance too. So chlorine has 3 in 1 molecule, so we make 2 molecules, so we'll have 6 chlorines. So I need to address that. 6 chlorines. Okay, now let's go ahead and address that sulfur. Again, so we had 3 sulfurs here, so we want to make this 3. So we put a 3 in front of the hydrogen sulfide. It gives us the 3 that we want. It also changes our hydrogens. It gives us 3 times 2 hydrogens. So we'll address that change. 3 times 2 is 6. All right, let's see where we're at. So we've got our irons balanced, we've got our sulfurs balanced. We still need to balance our hydrogens and our chlorines. So they're both in the same compound, hydrogen and chlorine, over here. Is there a way we can do this simply? Well, we need 6 of both. So yeah, there's a way we can do that simply. We just add a 6. And we're done. And that's how we do it. So there's our answer. So we'll move on to the next. Alright, so when we're balancing this equation, we just treat it like all others. We do our chart. And we list our elements: carbon, sulfur, nitrogen, and hydrogen. Make our rows. And we count. And this one might look pretty complicated at first, but let's go ahead and count and see what happens. So we've got, looks like one carbon on the left on our reactant side. Oops. We've got one carbon on the right on our product side. Sulfurs. We've got two sulfurs on the reactants. Two sulfurs on the products. Nitrogen, we've got one sulfur. I'm sorry, one nitrogen. One nitrogen on the reactants. Products, we've got two nitrogens. Hydrogens, three hydrogens on the reactants. Hydrogens, we've got 2, 3, 4. No, that's a nitrogen. 4, 5, 6 hydrogens. Alright, so it looks to me like we've already got our carbons balanced, we've already got our sulfurs balanced, you've got to balance nitrogen and hydrogen. Now, the most complex molecule, of course, is this guy here. We call that ammonium thiocyanate. We can start with our nitrogens or hydrogens. They're both in the same molecule over here, so we're really going to address them at the same exact time. So it doesn't really matter what we do. What we want to do is we want to put a 2 in front to address both of them, right? If I put a 2 in front of my, this is called ammonia, that's going to give me my 2 nitrogens that I need to balance out, and it's also going to get my 2 times 3, which will give me 6 hydrogens. So a problem that looks kind of difficult at first glance is actually quite simple. With one coefficient, I've balanced my entire reaction. There you go. Calcium hydroxide plus phosphoric acid makes water and calcium phosphate. Let's do our chart. We have calcium, oxygen, hydrogen, and phosphorus. So let's count. Don't let the parentheses fool you. Remember when we learned about these, what they mean. So our calcium, we only have one calcium on the left. Calcium's on the right. We've got the subscript 3 telling us we have 3. Oxygens. Remember, this 2 tells us we have 2 of this entire group. So 2 oxygens plus the 4 is 6. Oxygens on the right. This whole group, one of these groups has 4, so 2 of them gives us 8 oxygens, plus the one here is 9. Hydrogens, 2 hydrogens, 2 of these groups, plus 3, 6. Oh, that's 5. Hold on. Yeah, it's 5. We're not multiplying. It's 3 of these. Oh, it's my pointer. Yeah. 2 hydrogens plus the 3. That's 5. And here, looks like the only hydrogens we got are there, so 2. Phosphorus. 1 phosphorus. And looks like one of these groups has a phosphorus each, so 2 of them gives us 2 phosphorus. Alright, so again, pick the more complicated molecule or compound and start there. Most complex one is this one to me. So we'll start with that. So we can go with our calciums or our phosphorus first. I'm going to go with the calcium since there's more of them. And that means we need to get 3 calciums on the reactant side. So we'll put a 3 in front of the calcium hydroxide. Change that to 3. That means we've got to change our oxygen and hydrogen numbers. So we're just tripling the oxygens that we have present in each of these. So if we have 2 groups of these, so 2 oxygens 3 times. So that's 6 oxygens in here, plus the 4 here, so that's 10. And then that will be the same for our hydrogens, so that's 2 times 3 is 6, plus the 3 here is 9. Oops. Alright, so we've got our calciums balanced. Let's balance our phosphorus next. We have 2 phosphorus here, and we want to get 2 here, so let's change this to a 2. So that will fix the phosphorus. We have to change our hydrogens and oxygens again. So again, we have 6 oxygens from this substance, this representation here. 6 oxygens plus 4 times 2 is 8. So 6 and 8, 14. Again with the oxygens, so 6 from oxygens from, hydrogens, sorry. Still 6 hydrogens here. 6 plus 3 times 2 is 6 is 12. Alright, so let's see where we're at. We've got our calciums balanced. We've got our phosphorus balanced, but we do not have oxygen and hydrogen balanced. We always save hydrogen or oxygen for the end, so let's do our hydrogens. We've got 2 hydrogens on the right-hand side from here, so the easy answer to balance that out would be to put a 6 in front of that. So we'll do that. 6 times 2, of course, makes the 12 that we want. So that is the solution for our hydrogens. Now let's see what we can do about these oxygens, because that's the tricky part here, right? We have 9 on the right, and we want 14. So that's an addition of 5. And we're going to have to change something else in order to make that happen, which is okay. So if we have, let's use a different color here. So we've got 4 times 2, you've got 8 oxygens present here. We've got 6 oxygens present here. That's right, we just changed this. So we don't do that. We forgot to alter when we put our 6 in front of here, we didn't alter our number of oxygens again. So that's why something's not adding up. So we got to change that. So 6 plus 8 is 14. So we actually already balanced it. Isn't that wonderful? Again, the chart method showing us that it always checks itself a little bit, which is nice. So when we went to that step of balancing our oxygens, we actually discovered we had already balanced it, which is why I like this method so much. It's nice to have a method that kind of catches your mistakes sometimes. So again, what you saw there was me trying to make sense of this 9. And what I was doing, and I was figuring out how I was going to address balancing the oxygens by counting the oxygens up separately. And I recognized, oh, well, I had more than 9 because I forgot when I added the 6 to recount my oxygens. And so when I recounted it, I realized, oh, it's already balanced. So 3 and 3, 14, 14, 12, 12, 2, 2. This is our balanced reaction. The chart method is an excellent method. All right, the last problem we had was needing to balance C2H5OH, which is ethanol, plus oxygen gas, making carbon dioxide and water. So we do our chart, as always. Place our elements. Break it up into reactants and products. Make our rows. And we'll count. So we got 2 carbons in the reactants, 1 carbon on the right, 6 hydrogens on the left, 2 on the right, 3 oxygens on the reactants, and 3 oxygens on the right. And it's pretty clear what our most complex compound is, and that's the ethanol. So we'll start there. We'll do our carbons. So we have 2 carbons in the reactants, we need 2 on the products, so we'll rewrite that. Let's address our change in oxygens, which is now 4 oxygens here, plus the 1 here, which makes it 5. Now that we need to address our hydrogens, it looks like we got 6 on the left in our reactants, so we need to make 6 on the right. We can easily do that by adding a 3 in front of our water. So we'll do that. And now we need to address our oxygens, because we've changed those as well. So 3 times 1 oxygen is, of course, 3, plus our 4 over here, that gives us 7 oxygens. So it looks like everything's balanced but our oxygens. We got 2 carbons, 6 hydrogens, 7 oxygens here, and 3 oxygens here. So at first you might look and say, yeah, 7 is a yucky number. But when you look at and see that we have the oxygen split up, it actually makes it easier. Because what we can do is if we put a 3 in front of our oxygen here, that gives us 3 times 2 is 6, plus the 1 here is 7. So it actually works out perfectly for us. So we do that, and that gives us our 7 oxygens, and we are balanced. Not so bad. And that's it.